Welcome to Next Knowledge, the channel where we take you inside the world's most fascinating factories, uncovering the engineering, science, and automation behind everyday products. Today, we're stepping inside a modern Pringles factory, where ordinary potatoes are transformed into the iconic, perfectly stackable, saddle-shaped chips loved by millions around the world. This is a full-process documentary, from raw ingredients rolling off trucks to the final sealed can popping off the production line. We'll witness precision engineering, advanced robotics, food science, and quality control at its finest. So grab a tube of Pringles, but don't open it yet. Watch this first, because after you see what goes into making every single chip, you'll never look at that stack the same way again. This is Next Knowledge. Let's begin. The journey begins long before any factory floor. It starts in potato fields, where specific varieties of potatoes are grown exclusively for Pringles. Not just any potato will do. These are selected for high starch content, low sugar, and consistent texture. Sugar content matters because too much sugar causes dark, burnt chips during frying. These potatoes are harvested, transported in climate-controlled trucks, and arrive at the factory in massive quantities. Now, watch closely. The first stage inside the factory is cleaning. The potatoes are unloaded into a receiving hopper. Then they travel through a series of washing systems. High-pressure water jets blast away dirt, soil, and debris. Rotating brushes scrub the skins thoroughly. The water is recycled and filtered continuously. This isn't just washing, it's precision cleaning. You'll see the potatoes tumbling rhythmically. It's almost hypnotic, but every motion is engineered. The tumbling action ensures all surfaces are exposed to water and brushes. After washing, the potatoes move to peeling. Advanced peelers use two methods together: friction and precision blades. The friction removes the outer skin layer. The blades cut away any remaining imperfections. The goal is maximum yield with minimum waste. Peeled potatoes are then visually inspected, both by human eyes and by high-speed cameras. Any defective potato with dark spots, rot, or irregular shape is automatically ejected from the line. What remains is a clean, perfect, uniform potato, ready for the next stage. Now, here's where Pringles becomes completely different from traditional potato chips. Traditional chips are made by slicing fresh potatoes directly into frying oil. That method creates chips of irregular shape and size. They break easily, they don't stack. Pringles does something much more clever. The clean potatoes are first cooked whole, steamed or boiled until soft. Then they're mashed into a smooth, thick puree. Next comes drum drying. The mashed potatoes are spread onto large, heated, rotating drums. The heat removes almost all moisture. What comes off the drums is a thin, dry sheet of potato material. That sheet is then ground into fine potato flakes. These flakes are the secret foundation of every Pringles chip. Why flakes? Because flakes give you control. You can measure exactly how much potato goes into every single chip. You can blend them with other ingredients, and you can shape them into any form you want. Now the flakes are milled again, this time into an ultra-fine powder. That powder enters a massive mixing system. Here it's combined with water, vegetable oils, corn flour, rice flour, wheat starch, salt, sugar, and a proprietary blend of seasonings and emulsifiers. The exact recipe is a closely guarded secret, but we do know that the final potato content is about 42%, with the rest being other flours and starches that create the perfect texture. The mixture is blended into a smooth, pourable dough. Not stiff, not sticky, just right. This dough is now fed onto the first set of conveyor belts. It passes through a series of heavy rollers, some as wide as 2 meters. These rollers compress the dough into an extremely thin, uniform sheet. Thickness is controlled to within fractions of a millimeter. If the sheet is too thick, the chip won't fry properly. Too thin, and it breaks. Now watch the magic happen. The dough sheet moves under a high-speed cutting drum. This drum is embedded with oval-shaped cutters, thousands of them. As the drum rotates, it punches out oval pieces of dough at incredible speed. These oval pieces are called doughballs, a combination of dough and oval. The leftover dough, the scrap between the ovals, is immediately recycled back into the mixer. Nothing is wasted. Each dough ball now moves forward, and it's about to become a Pringles chip. The next station is the molding press. This is the most visually stunning part of the entire factory. Each soft dough oval falls into a curved metal mold. A press comes down, gently but firmly, and shapes the dough into the famous hyperbolic paraboloid form. That's a fancy mathematical term. In plain English, it's a saddle shape, curved one way along the length and the opposite way along the width. Why this shape? 3 reasons. First, even frying. The curved shape allows hot oil to flow evenly around every surface. Second, strength. A flat chip cracks easily. A saddle shape distributes stress, making it much harder to break. Third, stackability. The curves nest perfectly inside each other, creating a tight, uniform column inside the can. So this little shape is actually a masterpiece of structural engineering. The molded dough pieces now enter the frying tunnel. This is a long, enclosed chamber filled with hot vegetable oil. The temperature is maintained between 350 and 375 degrees Fahrenheit. That's about 175 to 190 degrees Celsius. The chips travel through the oil on a continuous belt. The journey takes exactly 11 seconds. Not 10 seconds, not 12 seconds, 11. Why so precise? Because frying is a chemical reaction. It's called the Maillard reaction, where heat transforms starches and proteins into golden brown colors and savory flavors. Too little time, and the chip is pale and doughy. Too much time, and it's dark and bitter. 11 seconds is the sweet spot. During those 11 seconds, something remarkable happens. The moisture inside the dough turns to steam and escapes rapidly. The starches gelatinize, the surface crisps. The chip transforms from soft dough into rigid, crunchy, golden perfection. The oil is continuously filtered to remove any particles. It's also tested constantly for chemical breakdown. Quality control never sleeps. As the chips emerge from the fryer, they pass over a drainage screen, allowing excess oil to drip off. Then they move into a cooling tunnel. Gentle fans blow room temperature air over the chips. This cooling is critical. If you package a hot chip, moisture condenses inside the can, making the chip soggy. If you cool too quickly, the chip cracks. So the cooling is carefully controlled, reducing temperature gradually over several minutes. Now the chips are ready for flavor. The seasoning process is a masterpiece of automation. First, a fine mist of flavored oil is sprayed onto each chip. The oil serves 2 purposes. It adds flavor, and it creates a sticky surface for the next layer. Then, the chips enter a rotating drum. Inside that drum, a powdered seasoning blend is sprayed under pressure. The chips tumble gently, not aggressively, because aggressive tumbling causes breakage. High-speed sensors monitor the amount of seasoning applied. If any chip gets too much or too little, the system automatically adjusts the sprayers. Whether it's original, sour cream and onion, cheddar cheese,
The journey
barbecue,
begins long
or
before
any of the
any
dozens of
factory
flavors
floor.
produced globally.
It starts in potato
The process
fields,
is the same,
where specific
only the
varieties
recipe
of
changes.
potatoes are grown
And the
exclusively for
factory can
Pringles.
switch between
Not just
flavors
any
in less
potato
than
will do.
15 minutes.
These are selected
That's
for high
efficiency.
starch content,
low
After
sugar,
seasoning,
and
the
consistent
chips pass
texture.
through another inspection
Sugar
zone.
content matters because
Cameras
too
check
much
for
sugar
color
causes
uniformity,
dark, burnt
lasers
chips
measure
during
shape.
frying.
Any chip that's
These
broken,
potatoes are harvested,
misshapen, or
transported in
unevenly
climate-controlled
seasoned,
trucks,
is blasted
and
off the
arrive at the
line by a
factory
jet
in
of compressed
massive
air.
quantities.
Only
Now,
perfect
watch
chips
closely.
continue.
The first stage inside the factory is cleaning. The potatoes are unloaded into a receiving hopper. Then they travel through a series of washing systems. High-pressure water jets blast away
Now
dirt,
comes the
soil,
most
and debris.
mesmerizing part of the
Rotating brushes
entire
scrub the skins
documentary,
thoroughly.
the
The
stacking
water is
process.
recycled and filtered
The seasoned chips
continuously.
are funneled into
This
narrow
isn't just
channels.
washing, it's
Each channel
precision
is
cleaning.
exactly the width of a
You'll
Pringles
see
chip.
the potatoes tumbling
As chips
rhythmically.
enter the channel,
It's
they
almost
naturally
hypnotic,
align
but
themselves.
every motion
Curve
is
matching
engineered.
curve,
The
saddle
tumbling action
matching saddle.
ensures all surfaces are
Vibrating
exposed to water
conveyors
and
gently
brushes.
shake the chips into
After
perfect
washing,
vertical
the potatoes
columns.
move to peeling.
It looks like magic,
Advanced
but
peelers
it's
use two
pure
methods
mechanical
together:
engineering.
friction and
The
precision
stacks
blades.
grow taller
The
and
friction
taller.
removes the outer
Sensors
skin
count every
The
chip.
blades cut away
When a
any
stack
remaining
reaches the
imperfections.
correct height,
The goal
usually
is
around
maximum
80
yield
to
with
100
minimum
chips,
waste.
depending on the can size,
Peeled
potatoes
potatoes
are
are
then
then
visually
visually
inspected.
inspected,
The stack
both by human
drops
eyes
into
and
a
by
waiting
high-speed
cylindrical
cameras.
can.
Any
This
defective
part
potato
is
with
so
dark
satisfying
spots,
to watch.
or irregular
The rhythmic
shape is
clicks,
automatically
the
ejected
perfect
from the line.
alignment. It's factory
What remains
ASMR
is a
at its
clean,
best.
perfect, uniform
The
potato.
cans themselves are
Ready
made
for the
from
next stage.
paperboard, aluminum, and foil. They're designed to protect the chips from light, moisture, and crushing. Once a can receives its stack, it moves to the sealing station. First, a burst of nitrogen gas is injected into the can. Nitrogen pushes out the oxygen. Why? Because oxygen causes the oils in the chips to go rancid. By replacing oxygen with nitrogen, the shelf life extends dramatically, up to 12 to 15 months. Then the aluminum lid is sealed on with precise pressure. Not too tight, not too loose. The familiar pop top is tested to ensure it opens easily every time. Now, the sealed cans move into the labeling machine. Labels are applied at high speed, wrapped perfectly around each can. The labels include barcodes, nutritional information, and the iconic Pringles logo, that smiling face with the mustache. After labeling, cans are grouped together, typically 12 or 24 cans per case. Robotic arms pick up entire rows of cans and place them into cardboard cases. These robots work with incredible precision. They never tire, they never drop a can. They operate 24 hours a day, 7 days a week. The cases are then sealed, palletized by another set of robots, and wrapped in plastic stretch film. Finally, the pallets are moved to the shipping bay, where they wait for trucks that will deliver them to stores around the world. From potato field to store shelf, the entire journey takes just a few days.
But before we finish, let's talk about what you don't see in the video: sustainability. Modern Pringles factories recycle almost everything. Water from the washing stage is treated and reused multiple times. Potato peels and rejected chips don't go to landfill. They're sent to anaerobic digesters that produce biogas, which actually helps power the factory. Excess dough is recycled immediately back into production. Cardboard and plastic waste are baled and sold for recycling. Some factories have achieved zero waste to landfill, a remarkable achievement for a facility producing millions of chips per day. Food safety is equally rigorous. All equipment is stainless steel, easy to clean and resistant to bacteria. The factory follows HACCP protocols, Hazard Analysis Critical Control Points. That means every stage of production is monitored for biological, chemical, and physical hazards. Workers wear hairnets, gloves, and sanitized uniforms. Air filtration systems remove dust and microbes. And automated systems mean human hands rarely touch the product. This is why you can open a tube of Pringles with complete confidence. Let me share some history. Pringles was developed in the 1960s by Procter & Gamble. The goal was to solve two big problems with traditional chips: breakage and air-filled bags. Consumers hated opening a bag of chips only to find crumbs and air. The solution? A stackable chip in a rigid can. The name Pringles came from a Cincinnati street, Pringle Drive. The original patent for the saddle shape was filed in 1968. And here's a fun fact: the official name on the patent is not Pringles. It's potato chip product in a container. Not very catchy. Today, Pringles is sold in over 140 countries. More than 50 billion chips are produced every year. And the originate shape hasn't changed in over 50 years because it's already perfect. So there you have it. From raw potatoes, to dough, to frying, to seasoning, to stacking, to sealing. Every Pringles chip you've ever eaten has traveled this exact journey. Through washing drums, molding presses, oil tunnels, cooling fans, seasoning drums, stacking channels, and robotic packers. It's not just a snack. It's a triumph of engineering, food science, and automation. Next time you pop open a tube and pull out that perfect stack, take a moment. Appreciate the journey. And maybe share this video with a friend who loves chips. Thank you for watching Next Knowledge. If you enjoyed this documentary, hit that subscribe button. Ring the bell. We have many more factory tours coming, from chocolate to cars, from sneakers to smartphones. Until next time, keep learning, keep questioning, and keep crunching. This is Next Knowledge, signing off.